Hello everyone, in this video I will do a quick introduction on learning how to use loops in MATLAB. In MATLAB you will be using two different kind of loops. The first one is for loops and the second one is while loops. So I will be starting this video with for loops and I will explain what they mean. So I'm just going to really quickly write an example of what a for loop is going to look like. So you started off by writing the word for. We then choose any type of variable. Usually we use the letter I. And for right now, I'm just going to do 1:5. I will explain what those are later. And then finally end. So this right here, this is what a for loop is going to look like. And if we want to see what is going on in between, I'm just going to type in display I. And I'm going to run it. So now let's talk about what is going on here. What a for loop does is that it's going to get this variable, and this variable is going to change as you iterate through the for loop. So what do I mean by iterate? Let's look at what I is being set equal to. 1:5. So what does 1:5 mean? If I go into the command window and type in 1:5, we see that this is actually a vector. And we can even confirm it right here in the workspace. 1:5 is a vector that counts from 1 to 5. So 1, 2, 3, 4, 5. So what this means? The way for loops work is that you can choose a variable, any variable. It doesn't even have to be the letter I. It can be the letter J, for example. It can be a word like index. So it can just be any variable you want. But usually we use the letter I. That's just more of the standard. So we set a variable and we declare it to a vector. So again, in this case, we're setting it to a vector being 1, 2, 3, 4, 5. Inside of this block, inside of this for loop, what's going on is that I is going to iterate through this vector. So again, remember this is 1, 2, 3, 4, 5. So on the first iteration, I is going to be 1. On the second iteration, I is going to be 2. On the third iteration, I is going to be 3. On the fourth iteration, I is going to be 4. And on the fifth iteration, I is going to be 5. So let's try using a different vector. Let's try, for example, 7, 8, and 9. And let's try running this. So as you can see now, on the first iteration, I is 7. On the second iteration, I is 8. On the third iteration, I is 9. And by looking at the output here, because we're displaying I, we can see that it's 7, 8, and 9. And we can put whatever values here, right? They don't have to be consecutive numbers. I could do 2, 4, 6, and 8. We can do even numbers. 2, 4, 6, 8. So what a for loop does is that it will iterate through a vector. So now this is really useful. Why? If you have any type of vector data and you need to quickly do some type of code through it, maybe you want to iterate the values to put in some formula, or maybe you simply trying to read what the values in a vector are. This is where for loops comes in. Another thing for loops are really good is by going back to the colon, it can be really good for counters. So if I want a for loop that runs 5 times, I can very easily just come here and set it as 1:5. So let's go back looking a little bit more back. So what exactly is a loop? A loop is code that you want to be run multiple times. So for example, let's say they have a variable and I set it to 2. And now in here inside this for loop, I'm going to say that x is equal to x squared. And then finally, I'm going to display the final value of x. So what do you think is going to happen when I run this? Let's find out. I'm going to click run. So as you can see here, a lot of stuff seems to be happening. Remember, since this for loop is going from 1 through 5, that means that this line right here is going to be running 5 times. And remember, MATLAB reads from top to bottom. So first we're going to start with x is equal to 2. Then it starts the for loop. So it's going to understand that this for loop is going to start through the vector 1 through 5. And we're saying that x should be equal to x squared. So right now x is equal to 2. So it's going to do 2 squared. So it's going to now understand that x should be 4. And if we look at our command window, we can see right here x is equal to 4. That was the first iteration. So now let's do the second iteration. So it's going to do again x is equal to x to the power of 2. In this case, our x is 4. So what is 4 squared? 16. So it's going to repeat this process 5 times. So 4 squared is 16, 16 squared is 256, 256 squared is 65,536. This number square is this even larger number here. So of course, it's a little bit of a weird example, but once you get more into the class, you will see why for loops are going to be really important. For loops are going to be really useful once you start getting into root finding, for example. And for loops are going to be really useful for whenever you have to iterate through a vector. For right now, I'm just going to leave it with this example. You're going to be, of course, assigned homework for these type of things. So you're going to be seeing a couple of more complex applications for there. But for right now, since I just want to introduce you to the for loop, I want you to look at this. Okay, so here's something else that we can also do with a for loop. So let's do something really basic. Let's say that we have a list of base and heights for triangles and we want to find the area for them. So first thing first, we can create a formula. So we can do area. So if you remember from the video about the data, we can do an anonymous function, bnh, and we're going to say that the area for a triangle is base times height divided by 2. So now let's say that we have a list of base values. So for different triangles, so for my first triangle, we have a base of 8. For my second triangle, we have a base of 6. And for my third triangle, I have a base of 2. So now my height values. For my first triangle, I have a height value of 7. For the second one, 4. For the third one, 5. So these are just arbitrary numbers I came up. So now I need to save my area value somewhere. So for this, I'm going to be using the 0 function. So for example, if I go into the command window, as you can see, if I can create a vector from 1 to 3, so this is a 1 row, 3 column vector. I'm going to call them values, and it's equal to 0s, 1, comma 3. So this is where we're going to store our answers. And here we can create for I is equal to 1, 2, 3. And all we have to do is now create. So now in here, this is where our iterator is going to be. So I can do values, open parentheses I. This is how we can access a key, or this is how we can access a certain element inside the array. And I'm going to use my formula, area, And again, since we're iterating, I can simply do base, and then as my key, I can just use the I that I have. Height, I, and we're going to plug this into our area formula and finish this off. So now instead of displaying X, I wanted to display my values. So let's see what happens here. So I'm going to click run, and I did a small typo. How do I know I did a small typo? If we read the error, it tells me a recognized function zeros. And if you see before, I did a small typo. So let me fix this. So now I'm going to click run, and as we can see, there we go. We have our area for these three triangles. If we want to, we can double check it ourselves. So one of the first triangle is going to be 8 times 7 divided by 2. I don't even have to do the calculation in my head. I can just see that it is 28. For the second triangle, it's base height of 6 and 4, so that would be 24 divided by 2, 12. And as you can see, the area matches. And same thing with this one, 2 times 5 divided by 2, that would just be 5. So I can use a for loop to iterate through all of this data. So instead of having to write every single thing individually, so for example, instead of having to do value 1 is equal to area 8 comma 7, value 2 is equal to area 6 comma 4, value 3 is equal to area 2 comma 5. So instead of having to type each of these individually, we can use a for loop and condense it into something like this. So now let's say that I have more triangles. I want to expand this into a fourth triangle. All I have to do is just add the base value, add a height value. I'm going to change this so it accommodates for 4 values. And I'm going to tell it to iterate through the 4 triangles. So for example, I can click run. And now we have this. We can generalize this further by creating a number of triangles values. So for example, n. And I can substitute this 4 with an n. And I can substitute this 4 with an n. So now let's say I have 5 triangles. So I'm going to add an extra triangle. So I'm going to add an arbitrary base and an arbitrary height. And then I can just change this to 5. And as you can see now, it's calculating the area for these 5 triangles. So as you can see, something to take away about for loops is that you can iterate through multiple data and condense what would normally have to do each one individually. You can now create generic code that would apply to multiple data. So in this case, we're applying code that will iterate through this array, and this array, and we're simplifying it into one single line. So for loops is something that you should really look into, and this will play a lot of bigger part once you get into stuff like root finding and regression. So now let's talk about while loops. So I'm going to delete this for now. So while loop is a kind of different way for you to loop over code. So with the case of the for loop, you specify the vector and the for loop would iterate. A while loop looks a little bit different. This is how they work. While end. And in here that would be a condition. So for example, something like this will be a valid while loop. So first of all, be a little bit careful with your while loops. If I were to, for example, set this to 5, oops, set this to 5 and run it, my MATLAB will freeze because it will be stuck in an infinite loop. So whenever you're dealing with while loops, just be a little bit careful. You don't want an infinite loop because then you would have to restart MATLAB and it's a little bit of a pain. So let's say that you accidentally run an infinite loop. For example, right here. So this loop will be running forever. What you can do is you can just click pause and then quit debugging. So that's something nice to know. That way you're not stuck in an infinite loop. So how do these work? You first specify while. This will let MATLAB know that everything right here is going to be a loop. And then right here you write a condition. So similar to when we work with if statements. So for example, this is what an if statement look like. This is a condition. And for the case of the if statement, this code would only run if this condition is true. So same thing with the while loop. This loop will continue running as long as this condition is true. So for example, let's say that we do this, and inside this loop we just have x is equal to x minus 1. And we're going to display our value. So let's see what happens when we run this. We get 4, 3, 2, 1, 0, and then our loop ends. And then we want to be double sure of that, we can also just add right here, loop finish. Because once the loop is finished, they will continue after this end statement. So as we can see, loop finish. So again, remember, MATLAB reads code from top to bottom. So it starts with x is equal to 5. It will then reach this while loop. It will check this condition. Is x larger than 5? Yes, 5, is x larger than 0? Yes, 5 is larger than 0. So it's going to run this code right here. So x will be equal to x minus 1. Since x is 5, this expression resolves to 4. So we're saying x is equal to 4. So we're going to display 4. As you can see, this is the first value that gets displayed. So now it goes back to the beginning of the while loop. Is 4 larger than 0? We know that that is true. So we'll run this code again. So x is equal to x minus 1. So now x is 3. As we can see, the second time around x is 3. Display x, do it again. So let's look at what happens once we reach in this step. If x is equal to 1, 1 is larger than 0, so this condition is true. This right here will be 1 minus 1, which is 0. So now x is 0. Display x, so we see that 0. So we'll jump back, and now we have this right here. Is 0 larger than 0? The answer is no. Since this condition is now false, it will stop running this loop and finish it. And then this is when this line gets run. As you can see right here, loop finish. So loops can definitely be a little bit of a complicated issue. The best way for you to get a little bit used to loops is by practicing them. So for this one, I suggest that you take you'd focus a lot on the homework assigned for this unit. If you ever need any help, you can always ask your professor or go to the tutoring where we do offer help for engineering classes such as numerical methods. For this one, right now it's a little bit tricky for me to give out some examples, mainly because a lot of the graphs for loops are going to come in once you start getting into the actual class. So for example, like the second or third unit. Right now, you're not going to be seeing a lot of loops, but this is definitely something to keep in mind. And it's something that you don't want to forget once you start getting into the meat of the class. So for right now, I'm just going to leave you with this. As I said, if you ever need any more help, you can always ask in the tutoring or your professor. Right now, this is just a quick introductory, and this is also like a quick reference. And once we get more into the class, we can go into more proper examples of actual applications for these. But right now, I just want to explain how to actually create these. So with that, thank you for watching this video and goodbye.